Bismillah ar-Rahman ar-Rahim. Now we'll continue. We'll start section 4.6, which is mainly what? A summary of curve sketching. The idea here is that we'll combine what you did in the prep year about sketching a curve and the things we did in the previous two, mainly in the previous two sections, a 4.3, 4.4. I know that in the prep year, we talk about x-intercept, y-intercept, symmetry, domain, all of these things we talk about in the prep year. In this course, in Math 101, yes, we talk about the continuity, I mean, and we talk about vertical asymptotes and horizontal asymptotes, which actually we did also in the prep year. Then we talk about these sections, which is how to check the behavior of the function from its derivative and its second derivative, increasing, decreasing, concavity, point of inflection, all of these things, and the asymptotes or the limits at infinity, and as x goes to infinity, x goes to minus infinity. So try to combine all of these things in one place, and we'll try to sketch a curve, the curve in general. So general, what are the guidelines? Determine the domain and the range. Sometimes it's very difficult to find the range, but if you can, intercept, asymptote, symmetry, and then do f prime and f double prime to find some information about the curve. So this is detailed guidelines about these things. Domain. What's the meaning of domain? What's the meaning? The domain is what? Is the set of values of x for which the function is defined. So see where the function is defined, that will be the domain. And if I know the domain, it means these are the only place where I will do the graph. The things outside the domain, I will do nothing about them. The values outside the domain. We have the y-intercept. How to find the y-intercept? Set x equals 0 and solve for y. That will give me the y-intercept. X-intercept the other way. I take y equals 0 and solve for x. And solve for x. Okay. Then we have the symmetry. If f of minus x equal f of x, then this function called an even function. And it will be symmetric about the y-axis. It will be symmetric about the y-axis. That means what? That means if you look at this graph, if I know this side, no need to do any calculation in this side. It just, I will think about the y-axis as a mirror. And then I graph the other part. And the same thing, if f of minus x equal minus f of x, then we say it's an odd function, and it will be symmetric about the origin. Now my mirror will be the origin. This will be my mirror. So if I know the graph of this side, no need to do any calculation in this side. Just I graph it where I consider 0 as a mirror. Okay. Now we'll go to the periodic functions. What do you mean by periodic function? If the function is repeating itself, if you look at this function from here to here, this is what I need. The other is just a copy. This side also. So it's just a copy. So they call it periodic function. How to check? I need to check f of x plus b. Will it be equal to f of x? It means for a periodic p, for a period p, this function is repeating itself. A very clear example, sine x or cosine x, where between 0 and 2 pi, this is one block, it will repeat itself. Asymptotes, we have the horizontal asymptotes, which is, I need to check x goes to minus infinity, x goes to infinity. If they are going to value, then we have y equal that value is a horizontal asymptote. Vertical, the other way. I want the limit as it goes to A from right or from left, going either to infinity or minus infinity. For rational functions, we know that the vertical asymptote I'll find it through what? Through the equating of the denominator after canceling any common factors. But for other functions, this method does not apply. Okay. Yeah. Then also we have a new asymptote, which is the slant asymptote. When I have slant asymptote, especially for rational function, it can be for other functions, but in this book, they are using it only for rational function. I have a asymptote when the degree of the numerator exceeds the degree of the denominator by exactly one, by only 1 degree. By 1 degree, then how to find the slant? Long division, and it will be the sum of, if you have this function, for example, you do the long division, you will get this. Right away, the slant asymptote y equal x, which is this. This will be the slant asymptote. As he's writing here, if you long division, then you will get it as a sum of the first degree polynomial zائد another rational function. But this one, I know that the remainder, this is usually the remainder. You know, when I do the long division, you have f of x over g of x equal q of x, the result of this long division, plus remainder over g of x, where the degree of r of x is less than the degree of g of x. Less than the degree of. So for sure, this limit as x goes to infinity or minus infinity will go to 0. So that will be your slant asymptote. So y equal q of x. Since the difference is only 1 degree, that q should be a linear function. That should be a linear function. That's mainly the idea. Okay, and then I will do the things which we did in 4.3 and 4.4. This is 4.3. And this is 4. Okay. We'll do f prime. We'll check the critical numbers. Divide the real line into critical numbers and the point of discontinuity. Find the intervals. F prime is positive, means f is increasing. F prime is negative, means f is decreasing. Then we'll find if f prime changes positive to negative, I have a local maximum. Then I have also local minimum the other way. And then also we can do the second derivative test for this case. If f prime at c is equal to 0. And if double prime at c not equal to 0, then I can do this test. Find local maximum, local minimum. Then also I can do if double prime to do the quantum inflection and concavity test. If it says concave up when f double prime positive, concave down when f double prime negative. Okay. And yeah, we can do also the inflection point. Then I combine all of these things in one place, and then I graph the. I do a sketch of the curve. That's mainly the idea. So we have domain, intercept, symmetry, asymptotes, then f prime and f double prime test. Then we sketch them. Let us do these things for this function. Okay. I have the domain, all real numbers except plus or minus 2. I think it's very clear. Intercepts. I have y-intercept. I will let x equal 0. That implies y equal what? Minus 18 over minus 4, which is 9 over 2. So I have the point 0 and 9 over 2. X-intercept, I will let y equal 0. I have what? 2 times x squared minus 9 equal to 0. So for sure I have x equal plus or minus 3. So I have the points 3 and 0 and minus 3 and 0. Okay, now finish the domain, we finish the intercept, symmetry. What I have as a symmetry? Yes, we have a symmetry. Very clear, f of minus x equal f of x. That means f is symmetric with respect to the y-axis. Then I graph only one part, the other part will be just a reflection about the y-axis. Asymptotes. Okay. For sure, there's a vertical asymptote, x equal 2 and x equal minus 2, very clear. Horizontal asymptote, same degree. So we'll take the division of the division of the leading coefficients. So y equal 2. That will be horizontal asymptote. No slant asymptote, because slant asymptote if the degree is more by 1. Okay, now we'll do f prime. F prime will be what? You can do the calculation, or you can. Yeah, sometimes it's a good idea not. Let me just get it from somewhere. F prime will be 20x to save time over x squared minus 4 squared. Okay, so it means when I do the real line, when I divide the real line, I'll use what? Yeah, I have point of discontinuity here. Don't forget that. And here at x equal plus or minus 2. So I have minus 2, and I have 2. Here, very clear, f prime equals 0 means x equals 0. So I have also the 0. This is what I will get from f prime. So now check the signs. This is always positive, since it's square. So we'll do this. It will be negative, negative, positive, positive. Means it's decreasing, decreasing, increasing, increasing. Okay. Then I will do the f double prime. Should have taken time to do this. This will be the result. Minus 20, 3x squared plus 4 over x squared minus 4 cubed. F double prime equal to 0, I'm getting nothing because this cannot be 0. So I have the real line. I will divide it only in minus 2 and 2, which is the point of discontinuity. So this is always negative, since this is positive times the negative value. So the control is here. Before minus 2, take minus 3. You'll get what? Negative or positive, that will be negative. And then 0, that will be negative over negative, that will be positive, and then that will be negative. So it's concave down, concave up, concave down. Then to graph the function, I'll try to put all of these, this one and this one in one place. So I'll put f prime here and f double prime here. So I have minus 2 and 0 and 2. So for f prime, it's decreasing, decreasing, and increasing, increasing. For f double prime, this is concave down, this is concave up, this is concave up, this is concave down. Okay, now we'll try to graph the function or assess the curve. That will give me what? Okay, we'll put the things. Y-intercept 0 and 9 over 2. This is 9 over 2. x-intercept 3 and minus 3 and 0, and 3 and 0. Yeah, they're almost the same. Symmetry to the y-axis. It means I will do the graph just in this side. The result, or in this side. The rest is just a copy or reflection about the y-axis. Vertical asymptote at 2 and minus 2. I have this is minus 2, also at 2. I have vertical asymptote. I have 2 is less than 9/2, so I have horizontal asymptote here. Also, it's a good idea always to check this horizontal asymptote will be crossed or touched or not. Is there an intersection between the curve and horizontal asymptote? I know the horizontal asymptote y equal 2 and the curve y equal this. So will these two intersect? I check. Make them equal to each other. And see, I'll have a solution or I have no solution. That will be 2x squared minus 18 equal to 2x squared minus 8. I'm getting minus 18 equal minus 8, which has no meaning. So it means they will not, this line will not be, there is no intersection between the horizontal asymptote and the curve. Okay, now let us graph the function. Okay, I'm graphing it from here. So between minus infinity to minus 2, it's decreasing and concave down. Decreasing and concave down. This line will not be crossed for sure. This is, so for sure my graph will be here, cannot be here. Because if it's here, it means I will cross the horizontal asymptote, which is not true. And it's what? Decreasing and concave down. So it will be something like this, which is decreasing and concave down. Okay. Now, between minus 2 and 0, from here to there, minus 2 to 0, the function either here or there. Since I have a point here, for sure it will be in this side. Now, at 0, I have a local minimum. So the function will do something like this. Well, it's decreasing, but it's concave up. This is 9 over 2. Okay. Now, since the function is symmetric with respect to the y-axis, the rest is just a copy. This is copy, and this is also a copy. That will be my function. And also I can check this. I know from 0 to 2, it's increasing, concave up, correct. And this one, after 2, it's increasing and concave down. It's increasing and concave down. It's increasing, but concave down. And it goes beside the asymptotes. Yeah. So the behavior of the function, as it goes to infinity, it goes along with the asymptotes. Or it approach the asymptotes. So that will be the sketch of the function. Okay. Let me take other examples. Here's another example. I want to do the same. Domain. All real numbers minus, except all real numbers except plus or minus 1. And it means the same thing. I have point of discontinuity. X equal plus or minus 1. Intercepts. I have y-intercept. I put x equals 0. For sure y equals 0. X-intercept. I'll put y equals 0. I'm getting برضو x equals 0. So I have only 0, 0. These are the x or y intercepts. Okay. Yeah. You sure I'm not missing anything? Symmetry. Very clear, f of minus x equal f of x. So it's symmetric with respect to y-axis. Asymptotes. What are the asymptotes? They have vertical asymptotes, x equal plus or minus 1. Horizontal asymptote, y equal to same degree. We have same degree, so for sure it will be y equal to the leading coefficients. Okay. And we'll do f prime and f double prime. F prime will be what? F prime, if we do the calculations, it will be minus 4x times this. So I will do, that means when f prime equal to 0, I have x equals 0. Then I will do this, include the point of discontinuity and the critical numbers. So before minus 1, I take a value. The same thing, this is always positive, so the control there. So take a negative value, that for sure it will be positive, that will be positive, that will be negative, that will be negative. That means increasing, increasing, and that's decreasing, decreasing. Okay. I'll do f double prime. If we do the calculation, f double prime will be this, 12x squared plus 4 over this. So my control is in minus 1 and 1. Since I have, this is cannot be equal to 0. Impossible to be equal to 0. So only they have the point of discontinuity. Take a value before minus 1. By the way, the numerator is always positive, so nothing to check. So I have minus 1 before, I mean, any value before minus 1, that will be positive, negative, positive. So this is concave up, this is concave down, this is concave up. I can make it in one line, so that will, as I did in the previous one, I think this is to make it easier for me to check. So I know this is increasing, increasing, this is decreasing, decreasing, and this is concave up, this is concave down, and this is concave up. Okay, now I'll sketch the curve. This is the, I'll put the information I have. So I have what? I know this is the point, 0, 0. Okay. I don't know, there is a vertical asymptote here. Minus 1. Also, I have another vertical asymptote at 1. I have horizontal asymptote at 2. By the way, horizontal asymptote will be crossed or not. Let me check. And is there a point of intersection between the horizontal asymptote and the curve? Equate them. I have 2x squared equal to x squared minus 2, which is impossible. So for sure, the asymptote will not be touched. There's no intersection between the horizontal asymptotes and the curve. Okay, now I will take a values. Now in this side, I am either here or there, I don't know. So if we take any value, take for example minus 2, so it is above 2 or below 2. Is it above this horizontal asymptote or below it? So check f of minus 2. Let me check f of minus 2. It will be what? 8 over 3, which is greater than 2, since 2 is x equal to 2. So I am here. For sure, I am on this side. Okay, I'm doing what? Concave up and increasing. And this is an asymptote, so it will go beside this. So that will be the sketch here. Here I have already point, which is this point. It's doing what? Concave down and increasing. So it will do something like this. It will go beside the asymptotes. Now I know the function is symmetrical to the y-axis. No need to do the calculation about the rest. Alas, this will be the other side, and this will be this one. And I can check between 0 to 1. It's concave down and decreasing. It's decreasing and concave down. Between 1 and infinity, it's decreasing, but it's concave up. That will be the graph of f of x. I wish it's clear. We do more examples. This is x squared over square root x plus 1. Now the function becomes a little bit harder, but we can do it. Inshallah. Domain. Domain will be what? X plus 1 positive. So that means x greater than minus 1. So my domain from minus 1 to infinity. So my only concern is about this interval. Other than that, it's not my business. Okay, intercepts. I will let y-intercept x equals 0. For sure, y equals 0. X-intercept, I have y equals 0. That gives me x equals 0. So I have 0, 0. Just 0, 0. Symmetry. No symmetry. Why? Because yes, this will be, if it with minus x, that will be x squared, but that will be minus x, where I cannot take the minus outside. So it will be no symmetry. Asymptotes. Asymptotes. Horizontal asymptote, I don't have horizontal asymptote. Since the degree is more. And it's not by 1, huh? So also there is no, because this is 2, this is half. This is degree 2, so the difference is not 1. So horizontal asymptote, no. Vertical asymptotes, yes. As x goes to minus 1, I have vertical asymptote. X equal to minus 1. Okay, f prime. Let me find f prime. After doing the calculation, that will be f prime. So f prime equal to 0. That implies x equals 0 and x equal minus 4 over 3. By the way, you have point of discontinuity at x. Oh, no need. Okay. Actually, it's endpoint. Okay. F double prime. Oh, I need to do the sign diagram for this f prime. So I have, actually, I'm starting from where? So starting from minus 1. So this is minus 1, open, up to infinity. This minus 4 over 3, this is out of the picture because it's here, outside the interval. So I will not consider. Halas, nothing to worry about. 0 is here, somewhere. So check only this. So between minus 1 and 0, take a value, minus half. That give me what? Negative. Here it will be positive. Because of the square root, that will be positive for sure. This one will be minus half. And this is, if you put minus half, it will be minus 3 over 2 plus 4. That will be positive, negative, so that will be negative. Okay. Take a value more than 0, 1, positive, positive, that will be positive. So it's decreasing, then increasing. Okay. I'll do f double prime. We do the calculation. You get f double prime equals what? Equals 3x squared plus 8x plus 8 over 4 x plus 1 to the power 5 over 2. Notice this one is always positive, huh? Why is that? There are two ways to do it, to check it. One way, if you noticed, if you take 3 as a common factor, then you have x squared plus 8 over 3x. If you add half of the coefficient of x squared, that will be 8 over 6, 4 over 3. So plus 16 over 9. 3 times 16 over 9, it means what? 16 over 3, which is less than 8. So that will be plus 8 minus 16 over 9. Now this is the function. I'm talking about f of x equal this, or g of x. That will be this. So it's 3. This is square, since I'm doing this. This is always positive. And this one is 8 is what? 72 over 9. So that will be what? 52 over 9 plus something like this. The meaning is that always positive. Cannot be 0, and it's always positive. So now to check the number line, I need only this minus 1, where this is my domain. And check the values before. The numerator is 0. The denominator for sure 0 is the square root, so this is always positive, so the function is always concave. Okay, so let me now graph the function. I have 0, 0. I have an asymptote here, minus 1. That's what I have. Okay. Now, yeah, if I want to combine it in one figure, let me do it here. Combine it in one figure. I have this is minus 1, and this is 0. And it's decreasing, then increasing, but it's always concave up. So I'll do something like what? Between 1 and 0, I can take a value. Actually, this is always positive. This function is always positive, very clear. It's always non-negative. So this is the numerator is always non-negative, and the denominator is always non-negative. So it's concave up and decreasing. So it will do something like this. It's doing concave up and decreasing. Then it's concave up still, but increasing now. So it will do something like this. That will be my function. Make it straight. So that's the function f of x. Other functions. Okay, as you can see, it's each function has its specialty. So we need to work all of these things. So what's the domain? The domain here is R. No restriction in x. X can be any value. Intercepts. Y-intercept. I will let x equal 0. So I'm getting y equals 0. X-intercept. I'm getting y equals 0. I'm getting also x equals 0. So I have 0, 0 is the only x and y-intercept. Asymptotes. Or symmetry. For that, symmetry. None. Asymptotes. Vertical asymptote, no vertical asymptote, very clear, since the function is defined everywhere. For horizontal asymptote, I need to check the limit as it goes to infinity of this function. So it will be infinity times infinity, which is infinity. No, from this side. But limit as it goes to minus infinity of this function, it will be what? It will be minus infinity times 0. And yeah, we need Lewis' rule in this case, which I will explain in 5.6. So what you will do is x over e is minus x. You just find the derivative of the numerator and the denominator. That will be 1 over minus e is minus x. Now plug it. That will be what? 1 over infinity, which is 0. So it means y equals 0 is a horizontal asymptote. But just only for this side, as this goes to minus infinity. As this goes to minus infinity. From the other side, it goes to infinity. The function is going to infinity. Okay, now we'll do f prime test. F prime will be what? We do the calculation. F prime will be x plus 1 e to the power x. So that means f prime equals 0. I have x equal minus 1. So I need to put this. This is minus 1. So I take a value before minus 1, minus 2. That give me negative. That give me positive. So it's decreasing, then increasing. Okay. Now we will do f double prime. That give me what? If we do the calculation, you get this. So f double prime equals 0 implies x equal minus 2. So it means I need to do this with minus 2 only. And it will be negative, positive. So it's concave down, then it's concave up. So I'll put them in one side, in one graph. I have minus 2. And also have minus 1. For f prime, this is decreasing, decreasing, then increasing. This is concave down, and this is concave up, concave. So let me now graph the function. Okay, I have 0, 0. This is the only intercept. No symmetry, vertical asymptote, only the y equals 0, which is the x-axis. This is horizontal asymptote. And in this side only. In this side, it will go to infinity. The function is going like this. But in this side, it will go to beside the asymptotes. Okay. Now, the most important point are minus 2. This is minus 2 and minus 1. So I check them. F of minus 2 will be what? It will be minus 2, e is minus 2. So it's minus 2 over e squared. F of minus 1, it will be minus e is minus 1, which is minus 1 over e. Okay, because I need these 2 points. Before minus 2, the minus 2 is somewhere here. Yeah. And this one will be bigger, huh? Minus 1 over e will be bigger than minus 2 over e squared. It's a negative, and they are negative values, but e squared will be greater than e by 2. Okay. That will be minus 2. And this is minus 1 over e. So if you think about the function is decreasing and concave down. So it will do something like this. I know this is an asymptote, huh? So it will do something. It's decreasing, but concave down until this. Then between minus 2 and minus 1, it's still decreasing, but concave up. So it will do something like this. You notice I make it very clear. This is up, this is down. And then after minus 1, it's increasing and concave up. And I know it's passing through this point. So it will pass through this point and do something like this. That will be the graph of the function. Yeah, maybe it's smoother than this, but I'm doing it so that it's very clear. It's concave down, then it's concave. Yeah, maybe to do something like this. Okay. Yeah. Make it like one curve. Another function. Yeah, by the way, in all of these functions, you can be asked about, for example, what is the domain, what is the range of the function? Is there any absolute maximum, absolute minimum? And for example, this one, no absolute maximum, no absolute minimum, since going to plus or minus infinity. I can say no absolute maximum, no absolute minimum. But the range of this function from where to where, the y values, they are from minus infinity up to 2, open. 2 is open, and from 9/2 to infinity. It's in the range. I'll do the same here. You have no absolute maximum, no absolute minimum. And the range of the function is what? It's from minus infinity to 0, closed, union from 2 open to infinity. The y value. Here, I have absolute minimum at x equals 0, and no absolute maximum. And the range from 0 to infinity. The range from 0 to infinity. Here, we have absolute minimum at x equal -1. No absolute maximum. And the range is what? This point is -1 and -1/e. So the range from -1/e up to infinity. That will be the range.